Okay. So, last time we gave a kind of a complete overview of this project, the Building the Awesome Bridges activity guide. We went through the whole thing. Today, we're going to talk about where we should be kind of by the end of today, what we should be doing today. And getting ready for next time. Let's see if I can get this to a full page view. Here we go. So everybody should have their build kit. If you don't have your build kit, please talk to me. I sent one out to Sergeant, so I'm hoping that it got there and that you got all the parts that you need. You should go through and take a look at all the parts. Don't necessarily get them all out and make a mess, but just take a look at everything that you've got so you know what you have available to you. And you should have at least some cutting tools, and I think I gave everybody a drill bit and a reaming tool. We talked about the engineering design process and how it's going to kind of fit this project a little bit. And at this point, where you should be, is designing your 3 options of bridges. By the end of today or by tomorrow at the latest, you should have 3 options of bridges or 3 possible bridge designs that you might use, and you should start evaluating them. So you can use the West Point Bridge Designer if you'd like. That can be helpful. Or you can just sketch them out on paper, and then once you've got a good sketch, you can put a permanent drawing down on paper. But you should have also written down what your problem is. You should also write down the design parameters or the specifications. It should be a 24-inch gap. And I think I said on Monday a 20-pound load, and I think I'm probably going to reduce that to a 10-pound load. 20 pounds is probably a little beyond what we should be doing. But we'll probably do a 10-pound load at the center, and it should be able to support that without, we'll say, without breaking. Okay? So nothing on the bridge should break with a 10-pound load. I considered even going down to a 5-pound load, but I certainly don't want to be a 2-pound load. 2 pounds is just a little bit too small for my taste. Let's say 5-pound load, just for fun. We'll go down to 5 pounds. I went and lifted 20 pounds the other day and decided that was too much. But we'll go to a 5-pound load. 2 pounds too little for our bridges in the past. So you need to use the parts that are in your building kit. We're not going to add in a bunch of things so that you have, parts that are just super long, super strong and all this. We're going to use the parts in our kit, make sure that you do that. And we will test the final bridge will be tested for deflection, and we'll allow up to about an inch of flex or an inch of deflection, and nothing breaks. You don't want anything to break. If something breaks, then it's a failed bridge. And this is really where you should be at this point. You should have filled that stuff out, at least by yesterday or the day before even. But you should be at this point where you're starting to design your bridge, and you've got alternative designs. You're going to brainstorm and you sketch things out on some paper. And then you're going to start to draw the bridge. You're going to draw the joints and the members, and you're going to label them. So in this case, every member of the bridge, or every piece of the bridge that is, let's see here, every piece of the bridge that is wire cable, they've labeled with C, and so if you're going to use a string or a wire cable, and if you want to add wire to your kit, that's fine, but nothing else than wire, nothing other than wire. But you can use string for the same thing, and so if they've labeled these all with C because they're all strings, and then they've got a couple of things in here that are not strings, that are not labeled C, and all the things that are not labeled are going to be, I assume, wood parts. They have plastic connector strips that they're going to label as well. They didn't label them. And here they have no label as wood, right? So you have a key here that shows what the parts are made of. And this is to scale. Notice that they've got this to scale because there are millimeter scales top and bottom, or centimeter scales top and bottom. You can change that to an inch scale if you'd like. It's up to you. But it does need to be 24 inches long in the end. Then they actually have a top view of the bridge as well. So up here they didn't show the top view of the bridge, but they certainly are doing a top view of the bridge so that they're showing that they have some members of the bridge going across the bridge, and so on and so forth. Here they're showing where those things connect just by using these extension lines that go all the way down. So they're showing where the bridge connects, and these two things should be to scale. The end of the bridge here should match up with the end of the bridge here. Right? If there's anything else that you're adding in, you need to make sure it's in. And in this particular case, the bridge is going to be, from above, it's going to have this slightly inward bend, and so they're showing that inward bend here, and that's fine too. But you should do that for 3 separate designs, and we have all that in here. So here they show 3 separate designs, and then they're scale drawings. And then they come down here and they measure the lengths of the members. For these members that are diagonal, you're going to have to measure them. For the ones that are straight along the x or the y-axis, you can just count off how many spaces per length. But you might have to use the Pythagorean theorem in some cases, or you can just measure them with a ruler and use a scaling. So if 1 centimeter square is 1 inch, then you can just use a ruler, and for every centimeter it will be an inch instead. And once you've done that, you need to record all the pieces of wood, plastic, and cable that you're going to use so that you know how much material you're using in each of your designs. Because that's part of what you're going to do to determine how good your design is. And once you've got that done, before you measure and cut, here they're measuring and cutting first. Before you get to the measuring and cutting thing, we want to go down to the end here to our alternative bridge designs, and we want to evaluate each of our alternative designs. If it meets the design constraints, if it's 24 inches long, for example, and it uses the parts that we have in our building kit, then you should rate yourself for how well you did that. For the functionality of the design, give yourself a rank. So if for example, if your bridge has beams that are crossing over the roadbed, it's not going to be a very functional design because those beams will be in the way. So you need to, and if it's a very skinny bridge, it's not very functional either. Skinnier the bridge, the less functional. The wider the bridge, probably the more functional it is. So on and so forth. Aesthetics, does it look nice? How nice does it look? How would it look good in a cityscape? If somebody was going to paint it, would they want to paint your bridge? And then the economy of this is essentially, how many parts did you use? So if you used a lot of parts, you're using half your kit on this project, for example, then probably it's not very economical. If you use fewer parts, it's probably more economical. And you're going to do that for 3 alternative designs. That is completely done on paper. You're not doing any building of these designs at all. Completely on paper and in your mind. And you're going to evaluate what you think is the best bridge. Once you have evaluated what you think is the best bridge, then you take that bridge and you go ahead and do a final design on this bigger sheet of paper. You list all the parts that you need, exactly what you need, length and everything for each part that you need, so that you know exactly how to cut out all the parts. And then you draw it out on these big pieces of paper where you can build, you can cut all these out and tape them together to make a really big layout, a really big design, a really big blueprint essentially that is, you can essentially do it full size. And then you can start to test and evaluate. What are you going to need to test and evaluate? You need these things, a camera, well, for those of you here in North Platte, we can test it in class. We'll use the class camera. For those of you not, you need your own camera to do a video of it. You'll need a photocopy of your final design, some colored pencils, things like this, and you're going to start evaluating them. That is further on. That is what we're getting to for Friday, so that you can have that all done by Monday in class. But you should be to the point today where you're getting ready to draw this final design. And this final design should be done by Friday so that you can start building, testing, and evaluating on Friday and over the weekend. So three alternative designs you should have done, you should get done by today, tomorrow at the latest, and you should evaluate them as well so that you can know what your final design is going to be. All right? Any questions? All right, I will be in my office if you need any help. If you need to email me later on, that's fine too, or call me later on. I'd be happy to help to look over your alternative designs, to help you with our alternative designs. But at this point, it's your job to get out there, research these bridges, decide what alternative designs you want to try out, and get them written down on paper. And I will be, like I said, available for any help that you might need from me or might want from me. And I wish you luck. You can use my classroom if you need a computer to work on. And we'll talk to you later.